I'll just hand over this session to my peer Bhavana to go on with what are robotics. What is robotics? So she'll start with the definitions. And guys, this is free. You can ask completely doubts. You can bug us. You can ask how many doubts you have. Just let us know what you want to learn. We are ready to teach. Just grasp how much of knowledge you need. Okay, guys, if anything is boring, just let us know. We'll change the topic. We can go on some interactive sessions and all. If everyone agrees with me, you can just raise your hands. So everyone is agreeing with me. It will all be interactive, right? Yeah, post yes in the group. Okay, so guys, is the unmute available in your? Can you unmute yourselves, or is there any problem? Yeah, can I hear some voices?
Yes, ma'am. Hello.
Yeah, it's
Hello,
good to
can you
hear
hear me?
voices, right? Just let me know. Like I am in this meet, it's like I'm only speaking. Just let me hear some voices. Just tell hi, hi, hi. That's it. That's more than enough.
Hi, bro.
Yeah, hi. Just let me know your voices, man. Not chat. Just let me listen to the voices.
Hello.
We can start interactive session. Yeah, hi, hi guys.
Hi.
Hi, bro.
Am I visible to everyone? Hi.
Yes, bro.
Okay, am I interactive enough and am I audible?
Yeah.
Yes, bhaiya.
Okay, so now let us start with the main what you have come for. Let us dive into robotics. Bhavna, the stage is yours. You can just dive into what robotics is.
Yeah, no, thanks, Anna. So I'm gonna present the screen. Just say if it's visible or not. Is the screen visible?
Yes.
Yeah. Okay. So before going to start, welcome guys. I'm Bhavna from RCS, and I'm a CSC student from second year from Sastra. So today we are gonna see the introduction to robotics and robots. So let's dive into the topic. So if you have any doubts, just raise your hand or put your doubt in the chat box. Okay? Can I receive a yes from you guys? Can I go ahead?
Yes.
So what are the topics we are gonna see today? What? Firstly, we'll see what is a robot, the basic definition of a robot, and then what is robotics. Next, the components used to make a robot, types of robots, and then the applications of robots. So the first question, what is a robot? So I've seen pretty well the responses from you guys in the chat box. So there are different definitions for a robot. Okay, so some say that a robot is a programmed machine, and some are saying that it is an artificial human, and some are saying that a robot is a machine that can sense, think, and act. So, like some robots can walk on their legs, and some use wheels or tracks, and some can take you to the skies, right? And some robots are used in space, hospitals, and while others are used in hospitals, industries, etc. And some robots, like they may be just small as 0.5 millimeter, and some may be as large as 15 meters. So based on this diversity in size, design, and capabilities, many definitions are made to the term robot. Okay. So there are many definitions to the term robot, and we are going to see some two standard definitions for this term robot. So one of the definition according to RIA, Robot Institute of America, is a robot is a reprogrammable multifunctional manipulator designed to move material, parts, tools, or specialized devices through variable programmed motions for the performance of variety of tasks. So we are saying that a robot is a reprogrammable device. So what does reprogrammable means? So just by changing the program of a robot, we can make the robot do a variety of tasks. We can make the robot perform different tasks. Okay. And the next term, multifunctional manipulator, right? So a manipulator is nothing but a human arm, or we can say manipulator as a robotic arm. So according to RIA, a robot is a reprogrammable multifunctional manipulator. And another general definition of robot is a robot is an autonomous machine capable of sensing its environment, carrying out computations to make decisions and performing actions in the real-time world. So we are seeing three of the important terms here: sensing, make decisions, and performing the actions. So sensing is just like the perceiving the data from the environment the robot is present, and through the data the robot should be capable of making the decisions, and through that it should perform the actions in real-time world. Okay, so I've seen someone answering the question that a robot is a machine that can sense, think, and act simultaneously. Is the definition of the robot clear? So we are not having a standard definition. We are having different definitions for a robot, but we use these two as the standard definitions of robot. Is that clear? Can I go ahead?
Yes.
Yes. And another responses, guys. Be interactive.
Yes, you can
Yes.
go ahead.
Okay, thank you. So next we'll move on to the term robotics. So what is robotics? Any guesses? What is robotics? Any answers? You can type your answers in your chat box. Branch to study about robots. Okay. Robotics design a robot. Great. And any more responses, guys? Okay. So robotics is a branch of technology that deals with the design, construction, and operation of robots. So robotics is like a branch of technology, like it is the intersection of science, engineering, and technology that produces machines called robots. Okay, so it integrates fields of mechanical engineering, electrical engineering, information engineering, mechatronics, bioengineering. So there is no one certain discipline or interdiscipline for robotics branch. So it is like a mix of various branches. Okay. So Sir Isaac Asimov coined the term robotics in 1942 in his science fiction Runaround, in which he also stated the three laws of robotics, also known as Asimov laws. So Runaround is a science fiction written by Isaac Asimov in 1942. In that science fiction book, he used the term robotics. But an interesting fact is that there was not even a single robot before coining the name robotics. So without having a single robot, the name robotics was coined. Okay. Next we will see the three laws of robotics. So we are having three laws of robotics. First law of robotics is a robot may not injure a human being or through inaction allow a human being to come to harm. It is saying that a robot should never harm a human being, and it should protect itself from causing a human to harm it. The second law states that a robot must obey the orders given to it by human beings, except where such orders would conflict with the first law. So it is saying that it should obey every order given by human beings, but the orders that it follows should not cause any harm to the human being. And the third law, a robot must protect its own existence as long as such protection does not conflict with the first or second law. And it should protect itself from humans causing any harm to it. And in this process, it should not hurt any other human being. Okay. So, okay, are you clear, guys? Is that clear?
Yeah, Akka.
Yes.
Okay, thank you. Next, machines and robots. So, what is a machine and what is a robot? And what is the basic difference between a machine and a robot? Okay, someone is asking to explain the first law. So the first law of the robotics states that a robot should not harm any human being. Okay, and it should protect itself from others harming it. So it should not harm any other human beings, or it should not. It should protect itself from others doing harm to it. Okay, is that clear? Karthik.
Yeah, it's clear.
Machine can't sense its environment and development. On other hand, robot develop itself. Machine consists of so many tools and robots. Is the some combination of machine. Robots is the sum. Okay. Okay. Great. Guys, what is the machine and what is the robot, or the difference between a machine and a robot? Can we call machine a robot? Is every machine a robot? Yes, Navya. No, but every robot is a machine. Yes. Not all times. Yes. Every robot is a machine. Yes. Okay. Great, guys. Now we'll see. So we can say a programmed machine as a robot.
Bhavana,
Yeah.
am I audible?
Yes or no?
There are 3 guys raising their hand. If there are any doubts, please ask them.
Okay. Yeah. Lakshmi Narayanan. Are you guys having any doubts?
Okay,
Yeah.
so raised at start of
Any doubts, guys?
You are not.
Yeah, no?
Guys, if you don't have any doubts, please try to raise down your hands. Just down your hands.
Okay.
And if guys, anyone have a true doubt, please raise your hands because this is an interactive session. So before Bhavana goes forward, now you can ask your doubts with her and she can go forward.
Yeah.
Bhavana, if there are no hands,
You
raised,
are-
you can go forward.
Okay, Anna. So a robot is a machine that can be programmed to do complex series of actions. Okay. And every robot is a machine, but every machine need not be a robot. Okay. And every robot should sense, think, and act. As we have seen in the previous slides, a robot should have the capability to sense its surroundings and make decisions from that data and act accordingly. So we are having washing machine, right? It is a programmed machine. Can we call washing machine a robot? Anyone? Can I make a robot which makes sense?
No.
No.
A washing machine, it is a program. Yet no one thinks of it as a robot. So, in addition to programming, the robot contains some additional characteristics that differentiate a robot from a machine. A robot should have the ability to respond to its environment autonomously and to alter its program and complete the task. And after completing the task, the robot should recognize that it has completed the task. So a machine can be considered as a robot if it can sense, think, and act simultaneously. Okay, guys. We are calling a machine as a robot if it can sense, think, and act simultaneously. These three actions, sense, think, and act, should be like interdependent to each other. Then we can call machine as a robot. So moving on to next slide. The three aspects of robots. We are having three main systems in a robot. One is the mechanical system, and the other one is the electrical or electronic system, and the third one is the intelligence processing system. So what is a mechanical system? A mechanical system, it aids in providing the rigidity for the body to perform the instructed operations in its workspace, considering the factors affecting it. So it helps to complete the tasks in the environment in which it is designed. The mechanical systems, it gives the robot the ability to complete the tasks in the environment which it's present. Okay. And next, the electrical and electronic system. It provides the control and power to the robot via the controller and the battery system. Like this is to power the machinery and other parts in the robot, like batteries and some other power sources to power the robot. And next is the intelligence processing systems. It includes a set of codes or instructions which tell the robot when and how to carry out the operation. Okay. So a set of instructions, a software or some codes which can tell the robot to do a particular task. It helps the robot to make decisions from the like the robot gets the data from the surroundings through sensors, and that data is used to make decisions. So it is called as intelligence processing. Clear, guys? Can I go forward? Any doubts? Can I go forward?
Yes.
Yes.
So the next topic is the key components of a robot. So what are the main components of a robot? We are having these 5 key components of the robot. One is the manipulator, end effector, controllers, sensors, actuators, and drivers. So what is a manipulator? A manipulator is similar to robotic arm or human arm, which can like help to pick the objects or grasp the objects. It works similar to human arm, and we can see the detail in further slides. And next one is the end effector. End effector, it is a device that is attached to the end of the robotic arm or the manipulator. Like it is the one which interacts with the environment, outside environment. Okay. It allows the robot to perform its task with the outside environment. It interacts with the outside environment. And next, controllers. Controllers, they command the robot to perform a specific task. Like it continuously reads the data from the sensors, and it is mainly used to make the decisions and command the robot to perform the task. And next, sensors. Sensors are the devices, like they take the input from the environment. These are the devices that detect the change in the environment and take the input, and then they convert the data into electrical signal and they give it to the controllers. And next, actuators and drivers. Actuators are the components which are important for movement of the robot, like motors, electric motors. So they convert the control signal which is given by the controller or a microcontroller or microprocessor, and they convert it into mechanical or some physical motion. They cause a machine to operate. And drivers. So drivers are used to regulate the power to the motors. Like they make sure that the motors are getting the electricity efficiently, and they also control the speed, direction of the robot, speed of the robot, acceleration and deceleration, etc. So is that fine, guys? Any doubts in this? The key components of a robot. Any doubts? We have used some technical terms here like manipulator and effector. So are you guys having any doubts? End effector and okay. So end effectors, they are like the devices which are connected at the end of the manipulator. Let's say our palm, which is used to which interacts with the environment, our palm with fingers, like used to grab the objects, etc. Right? So it is a device that is attached to the end of the robot, allowing the robot to interact with its task. So we'll see a picture in further slides. I can show you there what is end effector or gripper. And next, actuators, they're like motors, we can say, like they convert electrical signal given to them into some physical motion, right, into mechanical motion. They are used for movement of the robot. And drivers, they will control the power given to the motors, or they are the components which supply the electricity, which are in between the actuators and controllers. Okay, so they are used to control the speed, the direction based on the electricity they provide. Okay, is that clear?
Right, okay.
So let's see an analogy between humans and robots. Okay, so the links, joints, and wrist of a robot can be compared with the bones or skeleton of our humans. Okay, so the links, joints, and wrist are just similar to the bones we have or the skeleton. And these end effector or gripper are similar to our hand with fingers, our palm. Okay, so they are similar to our hand with fingers. And sensors, they are similar to the sensory organs we have to sense, like eyes, ear. So we use our sensory organs to get data from our surroundings, right? So sensors in robots also do the same. They get the data from the surrounding environments. And the heart and the muscles, which are used to like pump the blood and to transport the blood, are similar to the drivers and actuators. Okay, so they are the main components that drive the robot system for movement and all. And our brain can be, the controller of a robot can be compared to the brain of our human beings. Okay, so controller is just like a brain of the robots. So we humans, we use our brain to think. In a similar way, robots use microcontrollers to make decisions. So a computer a computer program runs this controller and gives detailed commands to the robot to follow. Is that clear? So our end effector is similar to the hands with our fingers. Is that clear? Someone asked. Can I go ahead?
Yeah.
So the next topic is types of robots. So based on the design and application, we are having some numerous definitions of robots. In the same way, we can classify robots based on many ways. We can classify them based on many ways. So here we classify robots based on mobility in two ways. One is stationary robots or non-mobile robots, and the other one is the mobile robots. So stationary robots or non-mobile robots means they can't move, or they are stable, they are fixed. And mobile robots, they can go through the environment, they can move in the environment. So in these stationary robots, we are going to see manipulators, and under mobile robots, we are going to see these 6 types of robots: AGV, ATV, electric bots, AMRs, AUVs, and UAVs. We'll be going to cover this in detail. So first, let's see mobile robots, automated guided vehicle, AGV, our first robot. So an AGV is a mobile robot used in industrial applications to maneuver in the manufacturing facility or a warehouse. Like the AGVs are just like the load carriers. You can see here in this video. So they are like used to transport the raw materials or the goods inside a manufacturing unit or inside a industry. Okay. So they are just like load carriers. They are also called as self-guided vehicles. So they use wires or some other types of sensors without any human intervention to move across the unit. So they follow some markers or some wires that are placed on the floor to detect their movement and to navigate around the place. So they have improved the production in manufacturing and they have removed humans from unsafe and some potentially dangerous conditions. And we can also overcome some possible human errors by using these AGVs. Okay. So we can simply put AGVs as a driverless vehicle used to move materials efficiently in a facility. It is a driverless vehicle. Okay. So it can reduce the labor cost because we are replacing them with the humans, and we can also reduce the product damage. Okay, is that clear? AGVs. Can I go ahead? Okay, thanks. And next type of robots is all-terrain vehicles, ATVs. We can call them ATVs or ATRs, all-terrain robots. So these are the category of mobile robots that are capable of navigating across bumpy and rough terrains. So these robots can navigate in uneven roads. As you can see in the video, they are used to climb the stairs and they can move in like unterrain, rough terrains. Okay, they mainly have wheels or tracks for locomotion. So they use wheels or some kind of tracks for locomotion. So these robots are having some off-road capabilities, some good off-road capabilities, and they have good grip over the uneven or terrain roads, and they can even uh, climb the stairs in ascending or descending. They can ascend the stairs or descend the stairs. And these ATRs have various link mechanisms in order to overcome various sized obstacles. This is one type of ATR, and this is having some type of link mechanism, and we can have different types of ATRs with different link mechanisms, so they can overcome different types of different size of obstacles. Okay, is that clear, guys? We interact, you guys. IS, we need a yes from you. Can I go ahead, or
I
are you
have,
having any doubts?
I, excuse me,
This Karthik.
I have wondered for what purpose that ATV is used.
AGV.
Yeah,
So
for
they
what
are
purpose
used
they are used.
AGVs. They are used like to transport the materials or the goods in a industry. Like for industry, we should transport the goods from one place to another place. After packaging the goods, we have to move them from one place to other place, right? So until now, we are using our human potential uh, or humans to do that. But these AGVs, they can like without the intervention of human autonomously, they can move the loads from one place to other place. As you can see in the video, wait, I'll show. So some
Bhavna,
wires or yeah,
Bhavna.
yes, ma'am.
Yeah, just let me take this one. Am I audible?
Yeah, bro.
Oh yeah, this AGVs are autonomously guided vehicles. You know line followed bots and all, right, guys? Yeah, some they will be following some QR codes and all. Similarly, AGV follows a few set points to reach to its destination and back. Basically, you want to move a load in a warehouse from point A to point B. So what you can do, you'll just use some person to use a crane and move that object from there to here. So from A to B, we have a fixed path. So there's nothing new. So from that point to B point, so it has to be guided autonomously. So So what do we have is we have few QR codes set along that path so that this AGV recognizes this QR code and goes to the set point. That is the warehouse point from where it has to move the product to point B. So from point A to point B, it takes the goods from there to here without any human intervention. So it is guided by those QR codes, like already pre-planned path is given to it. Is your doubt clear, Karthik?
Yeah, bro. Thanks.
Okay. Banu, you can continue.
Okay, Anna. And next. And next we have legged robots. So these legged robots are mobile robots that use mechanical limbs which provide active suspension for movement in highly unstructured environments. So these mechanical limbs are similar to our legs, the legs of our humans or legs of animals. These are similar to them and they are used for mobility in the environment. So they can traverse many different terrains. Okay. Uh, but the complexity in legged robots is uh, it is like somewhat complex to build a legged robot and teach the robot how to walk and how to balance itself. But um, legged robots are very useful. And we are having a question why legged robots are better than ATR. So ATR we have seen all-terrain vehicles, so which uses wheels and tracks for motion. And in legged robots we are using mechanical limbs which are similar to legs. So legged robots are far better than ATRs, and why? So legged robots are more versatile than wheeled robots as they can traverse in an unpredictable and rough environment efficiently. So these legged robots can travel in any different kind of surface like that which is an inaccessible by wheels. Okay. So do you have any thing to say about this? Like why legged robots are better than ATVs? So ATVs in the sense wheels and tracks. So why legged robots are better than ATVs? Do you have any idea, guys?
Maybe legged robots got more grip than the other one.
Okay. Any other answer?
Or they don't leave a trace.
Come again, Navya.
They don't leave a
Okay.
It can be brought back to the original position if it flips. Hello? Can you
Okay.
hear me?
Yeah.
Like, for example, wheeled robots, when they are flipped, they cannot go back to their original position. But when you have limbs, that can be relatively easy.
So ATVs, they are like we are having wheeled robots and robots which are having tracks. And the robots which are having tracks, even after flipping, they can get their original position back. So they can move into their original position. Okay. So these legged robots, they're like they can traverse many different terrains and on any kind of surface. So when an obstacle is placed before a legged robot or a wheeled robot. So what a wheeled robot should do is it should travel over the obstacle, like it should cross the obstacle by climbing it or passing it, or it should take a different path, like moving in different direction, taking a different path to avoid the obstacle. Legged robots, like they can just jump over the obstacle or they can like step over the obstacle. Okay. So in many ways, legged robots are better than ATRs.
Got-
Next,
Hello?
yeah,
I have a doubt.
yeah.
Like, can we have a combination of limbs and wheels?
Okay, it's a thing. It's up to our creativity. We can have, I guess. So these are some of the types of legged robots. We are having pogo stick robots, which is having one mechanical limb, and bipedal robots with two legs, tripodal robots, which are having three limbs, and similarly quadrupedal robot and hexapedal robot. So these are some of the types of legged robots. And next we are having AMRs, autonomous mobile robots. An AMR can perceive and move through its environment without being directly monitored by an operator or any predetermined course. Like AMRs are having some sophisticated sensors that allow them to understand and interpret their surroundings and help them to navigate around obstacles and reach their destination in the most optimal and effective way possible. So they use some advanced mapping technologies so that enables them to get to know the environment in which they are present. They can get the map of the environment in which they are present and they can move accordingly. So without being directly monitored by any humans, they can navigate through the facility or the unit autonomously. And there is no hardware particles like wires or magnetic tapes which are on the floor like to detect that one. It uses some algorithms, path planning algorithms, to move through the unit. Are you having any doubts like confusion between AMRs and others? Okay, rovers in Mars use wheels. Why do they use limbs as it's better? Legged robots, still researchers are working on that legged robots. Okay, so we humans are taking like years to know how to walk, and these legged robots, mm, like it's somewhat complex to build legged robots and teach them how to move and how to balance themselves. So there is an extensive research going on in the field of legged robots still. So, any doubts in AMRs, or are you having any like confusion? These AMRs, like they can perform free and natural navigation, and they can adapt to the changes in its environment easily. If the environment around it is changed, this robot can uh, change its path accordingly. It can adapt to the changes easily. So next we are having AUVs, autonomous underwater vehicles. An AUV is an unmanned submersible vehicle that requires no real-time input or control from an operator. AUVs are robotic vehicles that are pre-programmed with mission parameters and then deployed into the ocean. So before placing them into the ocean, these robots are pre-programmed. Okay, and we can use these AUVs for underwater search and exploration activities and like some survey missions underwater without any human or any other operator. So they can be used to study the ocean floor or to determine the characteristics of the water, the physical and biological characteristics of the water. So without any human or some any other operator, these AUVs can autonomously do all these things. So, and depending on their design and application, AUVs can drift or glide or propel themselves to the water. So, these are like the movements. Mm, these are the types of AUVs we are having: man portable AUVs, lightweight AUVs, heavyweight, and extra large. Based on the weights, based on their size, they are classified in these types. And next, we are having UAVs, unmanned aerial vehicles. So UAVs are a class of aircraft that can fly without the onboard presence of pilots. So we can say UAV as a powered vehicle that can fly without a pilot on board. So they are like aircrafts without any human pilot or some crew members. They consist of the aircraft component, sensor payloads, and a ground control station. These robots they can be controlled by onboard electronic equipment which are present on board on the aircraft itself, or via control equipment from the ground. Or we can control the robot from the ground. Human can control the robot like by using some control mechanism. And these are basically used for military missions. Okay, so they are similar to drones. Now let's see some classification of UAVs. So UAVs are classified based on wing type, based on the weight, based on the altitude they fly, based on flying height, and based on some special application and based on some range. So we can classify UAVs in based on different aspects. So based on the wing type, we are having rotary wing, fixed wing, flapping wing. Rotary wing in the sense they will have some blades, uh, and the aircraft will be powered by rotating blades such as helicopters. And fixed wings we have seen mostly in airplanes, so the wings will be fixed and they don't move. So fixed wings. Okay. And then the flapping wings, just as birds, like we can have aircrafts that can fly by flapping their wings. And based on the weight, we have micro UAV, miniature UAV, heavier UAV. So micro in the sense the weight of the aircraft should be less than 1 kg. And if the weight is between 1 to 25 kgs, we can consider it as a miniature aircraft. And if greater than 25 kg, we can have it as a heavier aircraft. And based on range, we have short range UAV, medium range, and long range UAV. And based on the altitude they fly, if less than 1 kilometer, then they are classified as low altitude aircrafts. And if 1 to 10 kilometers, medium altitude, and if greater than 10 kilometers, they are high altitude UAVs. And they can be so UAVs in addition, UAVs can not only fly in the air but also move on the water surface also. So like submarine launched UAV, submersible UAVs, seaplane UAV. Okay. Next, let's see applications of UAVs. So UAVs can be used in agriculture aspect, like I think you have seen drones used for fertilizing the land, for spraying pesticides and fertilizers, for crop monitoring, and for surveillance and monitoring, for transporting the goods, for transportation, for building systems, and like for video shootings. We we have seen like drones shooting the video of the programs or some events, and delivery systems like delivering the packages or delivering your goods, delivering your orders, and inspection, like when there is some dangerous place where humans can't go, we can use drones to inspect the area, to inspect disastrous zones, etc. So these are some applications where we are going to use UAVs. And before going to manipulators, we have completed mobile robots. Are you having any doubts? Any doubts, guys? I know it's past 7 and you are feeling bored. Can I go forward, or are you having any doubts? Respond, guys. Am I audible? No doubts. Okay, fine. And next, the important topic, manipulators. So a robotic manipulator is a mechanical linkage network which works similar to a human arm in its ability to reach, grasp and move. So it is similar to our human arm. They are also called as robotic arms. So they contain some link and join combinations. As you see here, there is a joint, link, and then a join. So joint link combinations are everywhere. So a joint, a link, a joint and the link, and next a joint. So links are like rigid members connecting the joints, and these joints, they are the movable components, and they cause the relative motion between the links. So they are used to move the robotic arm. So this is called the base, and at the end of the manipulator, we are having a end effector, or which is also called as gripper, to hold the things. Okay. So someone asked the end effector. So this is the end effector which will be placed at the end of the robotic arm. And we are having two types of manipulators, serial manipulator and parallel manipulator. So let's see what is a serial manipulator. A serial manipulator is a mechanism of several links connected in series by various types of joints. So this is an example of serial manipulator where you can see these are the joints and links, joints and links. So these are connected serially, and this is the base at one end which is fixed, and the other end of the manipulator is end effector which is free. So this is called an open chain manipulator. As we can see, one end is fixed and the other is open, and it can operate in larger workspace too. So this is a serial manipulator. And next, a parallel manipulator. Parallel manipulator. So as you can see, this is a parallel manipulator. So having a fixed base and a platform or end effector which is able to move, a mobile platform, and these are the joints, and these are connected in so at both ends they are closed. So this is also called as closed loop chain manipulator. um, yeah. A parallel manipulator is composed of a mobile platform connected to a fixed base by a set of identical parallel kinematic chains called legs. So these joints are also called as legs, and we are having some different types of joints. Um, Two major types of joints are prismatic joints and rotary joints, and we are having a dedicated session on manipulators in further sessions. In these 14 days of robotics, we are going to have a session based on the manipulators, where you can see complete kinematics of manipulators and more about the manipulators. So before moving forward, is that clear? Any doubts, guys? Okay. Can I go forward? Okay, no doubts. We have reached the end, guys. Only one topic is left. That is the application of robotics. I want you guys to answer, where are we going to use this robotics, applications of robotics? In which fields we are going to use robotics? There are many fields we are using the robots. So name some of the fields where we use robotics, some applications. Automobile industries, okay. Defense industry, space organization, okay. Healthcare and surgeries, okay. Space research, food industries. Come on, guys. That's it, medical, Okay. Okay, let me continue. So these are some various fields where we use robotics. So first one is the space exploration. Okay. So sending a robot to space is much cheaper than sending a man. Even NASA says this. Like NASA says that robots can survive in space for many years and can be left out there, and no need for a return trip for them. If they are like sending robots, there is no need of return trip and there is no need of food and some other accommodations, right? So, and these robots can also withstand harsh conditions like extreme temperature and high levels of radiation. They can withstand these types of conditions. So we can use robots in space exploration. And next in agriculture field, we have seen drones, many drones which are nowadays used in agriculture for spraying the pesticides and all. And for weed control, we can use robots for harvesting, for some environmental monitoring, that is detecting the temperature, moisture, humidity of the weather, and soil analysis. We can use some sensors to analyze the soil, and we can use robots in agriculture. And next, health field. So in health field also we can use robots that can assist the doctors during surgery times to hand over some things like some scissors or some kind of medical stuff. And they are also can be appointed to take care of elderly patients or some disabled patients, um, to supply them the medicines, to take care of them, and for taking blood samples, for checking the temperature, improving patient hygiene, etc. And next, underwater exploration. We have seen AUVs where we used um, some unmanned underwater vehicles to explore the surface of the ocean, or to get the um, to get some details which human can't be able to get them under oceans. And in manufacturing sites we can use them like manipulators. We have seen manipulators, they can be used in manufacturing sites, and we are seeing AGVs and AMRs which are also used in industries or manufacturing sites. And then military for defense, and robotic technology is not new in military applications. Like they can perform various roles, for combat roles, for rescuing tasks, and for explosive disarmament. Can use robots like for fire support and etc. So these robots can also be, they are like alternatives to human soldiers. And there are many more fields where we use robots for entertainment industry. We can use robots like to handle the cameras, that stuff. We can use robots in many other fields. Are you guys having any other ideas, like any other fields where we use robots? Robot camera used in televisions. Okay. So any other application, or can I go forward? Are you having any doubts, guys? Any doubts? So we have completed our agenda. We have completed like what is a robot. We have seen the definition of robot, the definition of robotics, the components that are used to make a robot, and then the types of robots, various types of robots, mobile robots and manipulators. And then we have also seen the application of robots. That's it, guys. So the speakers today, myself Bhavna and Yashwantanna. So these are the content creators. You can follow us on our LinkedIn profile, or you can contact us through our Insta. So we have provided our Insta IDs and LinkedIn IDs, LinkedIn profiles. And next, so for further updates regarding any events, follow our RCS page in LinkedIn and in our Instagram. So these are the links. I think we'll provide them in the chat. Thank you guys. So I think now we are going to fill the feedback form and some this I guess. So don't go out of the meet. Fill the feedback form given in the chat. Any
Okay,
doubts,
Bhavna,
guys?
thanks.
Yeah, posted, Baba.
Okay, now I'll just take it up. It's okay with everyone.
Okay, now I'll stop presenting.
Yeah, juniors. Sorry, the presenters. Sorry, the participants. Everyone. You listened very patiently and waited for me. I am back. And anyone having any doubts, please let me know now. It's a Q&A session. So I'll just answer everyone's doubts, and myself, I'll be explaining anything you want to re-explain this thing, and you want to know anything about such a thing. I'll be just re-explaining, and I can show you the PPT and all. So please just utilize it 100% because we have a lot of time. I think more than 15 minutes are there. Please go on. Yeah, is everyone on? You can just raise your hands and tell me that I am in the meet and I'm still awake. Okay, so you don't have any doubts. So everyone is perfect with everyone knows everything now. Yeah, you will be getting this PPT, Himanshu. It's not a problem. I think they already shared the link. Can I listen to your voices, guys? Hey, guys, tell me hi, something like that. Something which you learned. Just share me your review on this. Like, what you learned from the first. Like, I heard some 3 laws were told in this. Can anyone explain me what about the 3 laws?
The
Yeah,
three laws
anyone is
of
welcome to
food.
speak. Yeah,
Hello, I'm audible. Hello.
you're audible.
Yeah.
Yeah, you're
The
audible. Just
first
go on.
law, yes. The robot can. The first law is the robot can't harm any human being. Second law is that he fulfill all the commands of human until the first law break. And third law is he will protect himself until the first and second law break.
Okay, any more inputs, guys? Hey, how many of you seen the movie I, Robot? Guys, no one has watched the movies. Just raise your hands who have watched the movie.
Now, which movie? The name is not clear.
I, Robot.
Terminator movie.
Yeah.
I like Terminator movie.
Oh, okay. So you can see the robots acting against humans' wills, right? Those robots doesn't obey to humans and all, right? They just start attacking their creator.
So I saw Wally.
Oh yeah, Wally is a good movie where you can see a robot trying to save its planet.
Yeah, that's the
Any
future.
more? Yeah, that's the future. We obviously know we want to space travel and explore, so that's not a problem. Guys, was this session interactive? I never found you guys answering. Was it too boring? Just answer my question so I won't repeat the same mistake in my second session.
Hey, just think me as your friend. I'm not a teacher or I don't have your marks and all. So please just let me know so I can improve the session because we are going to travel for 14 days. So our first day ends today. So just let me know what you want and how was our session and was it interactive enough and all. Yeah, Karthik, Tushar, Malneni, Saksham, anyone can answer. I'm just reading out the names which are visible on my screen. Yeah, Vandana, Lakshmi, Narayanan. Anyone? Hey, am I audible?
Yeah, bro.
The technical crew.
Audible and
Am I audible?
You're
audible.
Yeah, audible.
Yeah, guys, you are not answering. Was it too boring? Just be frank with us. Because this is something to the robotics community. So we want to develop as a community. So we want everyone to take, we want to take inputs. We want to learn from you also, like what, where we are struggling and what we have to do. So just let us know what are the problems with us and any Q&A regarding any manipulator. And basically, why do we use manipulators and where have you seen such things? Has anyone seen a manipulator in the really? Guys, answer this at least. Just raise your hands or something. Oh, I think everyone is sleeping after this lecture. Okay. 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 So after this session is, I think, Dheeraj, can you post some questions regarding this? There's a, I think you can share a quiz form. Dheeraj, technical crew.